everyone, it's Miss Goobrood. Welcome to lesson 2-4. We're going to be finding the area of any triangle. So we already know how to find the area of right triangles because we know a rectangle, when you cut it on the diagonal, makes two right triangles. So we know the area of a right triangle is a half of the base times the height of a rectangle. But today, we're going to talk about what if the triangle isn't a right triangle? What if it's an obtuse triangle? What if it's an acute triangle? So that's what we're going to be investigating today. So let's start out by, I'm going to minimize myself here. Let's start out by talking about the different types of triangles that we might have. Oh, I just moved myself. I didn't minimize myself, did I? There we go. Holy cow. I'm having a hard time. Oh no. All right. So, first of all, there's a fantastically get stuck in your head song called The Triangle Song by the Bazillions. I think you may have already watched it in one of our earlier lessons, but if you didn't, go into our vocabulary slideshow and click on Triangle Song, or just search it up, Triangle Songs by the Bazillions. It'll get stuck in your head, I promise. So, triangles are classified in two ways. And both names are frequently used together. So, for instance, you could have a right scalene triangle. You could have an acute, I keep doing that. You could have an acute isosceles triangle. You could have an obtuse isosceles triangle. So triangles are classified two ways, and they often have two names. Why does equilateral triangle only have one name? Think about that for a minute. So the two ways we could classify triangles is by their sides, the length of their sides, or by the openness and shutness of their angles. So we're going to talk about degrees today. You're familiar with degrees? We always think about what are the degrees outside, how warm or cold something is. We measure it with a thermometer. Some thermometers we use to measure our own temperature, like if we're sick. Some thermometers we use to measure the outside temperature to say, it's 32 degrees outside, or inside our house to say, it's 72 degrees inside our house. The temperatures are written with a number, followed by that little circle up and to the right, like there. Oops, if I scroll over it, it covers it up. There it is. Example, 92 degrees might be a super hot day, or 13 degrees is a cold winter day. So here I am doing my math video example. All right, we're back. You got me. The degrees of a triangle. Nope. It's not the temperature. The degrees of a triangle are not the temperature. It's nothing to do with temperature. We use the same word, degrees. So we would talk about the degrees of a triangle or the degrees of an angle, but it tells how open and shut two lines are from each other. It has nothing to do with how hot or cold something is. So this thing I'm holding up right here, this is how we actually measure the degrees of a triangle or of an angle to see how open and closed they are. Let's see. There we go. It's called a protractor. And you can see, I got to move my head here. You can see that how open or closed this angle is, like this, we measure the number of degrees. If it was just like this, it would be 0. A little bit, maybe that's like 5 or 10, 15, 20, 25, 30, 35, 40. Halfway to a square corner is 45. All the way, we're opening that angle up further and closing it, just like the opening or closing of a door. If a door is only a tiny bit open, it's super hard to get through. If it's a little bit more, it gets easier, all the way until it's 90 degrees. Now, you can't really open a door usually much more than 90, but you might be able to, and angles open even further. As a matter of fact, they open all the way up until something I can't do with my hands, until they're all the way, they keep going even past 180. When you get to 180, that's called a straight angle. Weird name. Why can it be an angle if it's straight angle? But they can go all the way around to 360 degrees. So the wider the angle is open, the bigger the number of degrees. The smaller the angle is, the smaller the number of degrees. So that brings us to acute angles. Acute angles, we call them acute angles because all three of the angles are less than 90. They're cute little angles. That helps me remember. If you have to say it like that with that kind of that baby voice, like, oh, it's such a cute little angle. So if you say it like that, you're going to remember it. All of the angles have to be 90. If they have one 90-degree angle, they're called a right angle. So that wouldn't be an acute angle. If they have an angle that's bigger, and only one that's bigger, they're called obtuse. Again, that wouldn't be acute. If all three angles are 60 degrees, they're called equilateral. So it's only if they have all three and not one that's a right, not one that's an obtuse, and not all three that are acute. That's tricky. So those are acute triangles. Obtuse triangles. An obtuse triangle has one angle that we're concerned about. It's the one that's bigger than 90. So if any triangle has one angle that's bigger than 90, it's automatically obtuse. All right, we're going to come back to figure out the area of any triangle next time. So let's go into our workbook.